Hello.
Hello.
Hi, Itai.
Yeah, yes, that's correct.
Yeah, too many letters, so the chances were not too bad that I pronounce it.
Yeah, it's okay. Let me just fix my video from some reason. I'm blurred. Yeah, anyway. And you, Henrik, right? I cannot hear you from some reason. I still cannot hear you.
Yeah, now it should be better.
Yeah, thank you.
Does it? Perfect. Yeah, sorry, I found the right option and menu setting. All right, so I was saying there is the OpenSSF Summit taking place in Vancouver, I think. And so let's see how many other people will join. I also haven't been there last week because I was on a full week seminar, so I'm not sure whether there was any progress happening. Do you know by chance?
No, actually, I won't be able to make it for this summit. This conference, have you been to one of these before?
No, I've never been to an OpenSSF summit.
Yeah, okay. Okay, you think someone else is gonna join this meeting?
I can't tell. I don't know. I suggest we wait a few more minutes and then the two of us decide whether it's worthwhile doing it together or whether we skip this session and wait for next week when maybe more people are back from Vancouver, as you like.
Yeah, in the meanwhile, I can introduce myself, just for us to get to know each other. So basically, I came from Cisco. I guess you know this company. I'm located in Tel Aviv, Israel. What we do is we are working on security products. So basically, I'm a product manager in our team. Yeah, basically we are working on software supply chain security platform. Specifically, I'm interested in the Salsa framework, which is what brought me here in the first place.
All right.
Yeah, that's basically it.
So you were working for Cisco, or you're still working for Cisco? No, I don't. You moved.
Yeah, I am still working in Cisco. Actually, I came to Cisco via an acquisition. Before that, I was working for a startup company named Hexagon, basically an observability platform, which was acquired by Cisco 2 years ago.
Okay.
So yeah, I came from the back door, basically. Yeah, that's basically my story. And yeah, I was just starting to educate myself about the Salsa framework, which is, from what I saw, is the only software supply chain dedicated or CI/CD dedicated framework, security framework out there, which is the most mature one from all the rest.
Yeah, I think it is. I think it's very. I like it also. It is a little bit, or maybe it's just the parts that I didn't see, but sometimes I have the feeling it's a little bit high level, right? So they describe requirements on a high level, which of course is a good thing, but then breaking this down to concrete technologies is maybe not straightforward. But I understand this cannot be all covered by the high level Salsa framework. So I kind of see the trade-offs. Where do you start and where do you stop? And it makes a lot of sense what they have done. Maybe you can look into the software component verification standard from the OWASP, which is also a nice effort in this space. It's not only about supply chain attacks, but also about this problem of using components with known vulnerabilities. But there's also a lot of meat and value in this other framework.
Yeah, I can relate with what you are saying. Definitely, this is one aspect that is lacking right now from Salsa, and actually I see this as a challenge that we need to solve. And actually, this is what brought me to engage in these meetings. I don't know if this meeting specifically is gonna, this is one of the goals of it. But I'm trying to figure out where I can have my take and to share knowledge.
Yeah, maybe I can provide a little bit of background. So it's the first time you dial in?
Yep, actually yes.
Okay. So the idea of this effort is that John Meadows and other people from the end user work group found that from an end user perspective, it would be very helpful to have a kind of general architecture of different software organizations, software development organizations of different sizes, run a threat modeling on such generic infrastructures, development infrastructures, as a means to explain to end users how and where all the different solutions and initiatives and technologies provided by the OpenSSF fit. Because there's so much work going on OpenSSF, so many different discussion threads and developments that sometimes maybe it's a little difficult for consumers of all this information to know what to take in order to counter which specific threat. And so the threat modeling workshop we are running was meant to help this effort of drawing a map of OpenSSF in terms of how do the solutions solve concrete threats in a typical software development environment. Right. And so we have started. I mean, I can walk you through the diagram, and we can. Actually, I would be happy to have your feedback, and maybe you have some comments and suggestions and extensions that we can integrate on the fly. So like this, you get a.
And if you can please introduce like yourself, where you come from.
All right.
A little bit about
of course.
Yeah.
Okay. So I've been working for a number of years on this whole topic of open source supply chain security. I started back in 2012. There was a great article from Jeff Williams called "The Unfortunate Reality of Insecure Libraries" that triggered me back then. And in the first, I would say 5-6 years, it was all about the problem of using components with known vulnerabilities. And so I developed some static and dynamic program analysis tools that let developers understand the impact of a vulnerability somewhere deep in the dependency tree on the specific application. And so it was all about, can I reach the vulnerable method from the application that I have, right? And then starting 2019, I started looking into the supply chain attacks where people injected malicious code into open source components together with the University of Bonn. I wrote a research paper called the Backstabber's Knife Collection, where we basically collected at that time like 200 malicious packages that we found on PyPI, Ruby Gems, and NPM, and we looked into all kind of characteristics. And we also maintain a public data set in order to support researchers in the development of preventive and detective safeguards. And so that data set keeps on growing because we have some people contributing malicious packages that they take off the registries. And yeah, just now for a couple of months, I'm working as a security researcher with a startup called Endor Labs. That's a quick overview about.
What does this company do again?
We develop basically a platform to support developers in the secure consumption of open source. It's all about managing security risks in regards to open source components, not only security, also operational risks.
Okay. And, third-party software suppliers and things like this.
Exactly. It's all about basically analyzing your application, understanding what is the risk for you that comes with all the open source components you consume during your software development.
Yeah.
Life cycle. Exactly. So let me try to bring up my document or our document, and I'm going to share. So do you have a little bit of background in threat modeling?
Yeah.
It's
like, from the research I did, nothing practical, basically.
All right. Okay. Yeah. So you didn't moderate or you didn't run any threat modeling workshops, because I feel sometimes this is what we need. I same here. Kind of. I know what threat modeling is all about. I also participated, but I never really moderated one. And I think this moderation experience is something that we will need going forward.
Yeah.
But yeah. Let me share a link here. Share.
So you say the community is missing people that's doing a real live threat modeling by hands-on threat modeling, basically.
I wouldn't say the community, I guess, but more the people in this particular meeting that run the threat modeling of this generic high-level development architecture. And maybe I can explain a little bit more in detail if you go to the document that I shared the link for.
Yeah, I see it.
All right. And so basically here, what you see in the beginning, I've written down some kind of objectives, and then the large, what we thought is a generic high-level architecture of a development infrastructure of a large-scale software development organization. And what you see here is basically the different systems, starting from the workstation to version control systems, build systems, internal private registries, up until public distribution platforms. And between those systems, you have flows of either third-party code, including open source, in red, or proprietary code in blue. And so here we have all those data flows from the different systems and stakeholders. Right, and then we started basically defining what are the assets, kind of the initial assumptions and scope and so forth. And we stopped the last time I attended the session, that was 2 weeks ago, looking at the flows of third-party code. So we and we basically looked at each of the data flows and described a little bit in more detail what is the source, what is the sink of the data, and what is the purpose of the specific flow. And once we have those data flows complete, I guess we can proceed with describing the threats, right? That is kind of the idea.
Yeah.
Maybe I think it would be fine if you just, scroll a little bit through the document and use the opportunity we can use the opportunity to discuss it, just the two of us. I think that is a valuable exercise if you.
Each of these blue boxes are kind of trust boundaries, for example.
No. We didn't draw any trust boundaries yet. For me, so we kind of discussed this, and we came to this conclusion that for the time being, we do not want to also cover insider threats.
Yeah.
And this is a consequence of excluding insider threats, I think, is that the trust boundary can be drawn between basically the outside of the trust boundary is the distribution platforms, such as open source distribution platforms for source code or binary packages, PyPI, GitHub, and so forth, or even proprietary distribution platforms such as download servers also from commercial third-party providers. So all that is out, and basically everything else is in the trust boundary.
Yeah. Okay. So thank you for sharing this document with me. I have a general question regarding this one. So let's say these models. Okay, who's the personas that are gonna consume these models and these guidelines? So I'm asking, who are the personas within a software organization that has the challenge and has the pain and need to consume these threat modeling and to be able to model their system in such a comprehensive way, right?
Yeah, so I think, here we talk of the example architecture we came up with is that of a large-scale in-house development, right? So this would be bigger software corporations with hundreds and hundreds of developers. And for those guys, there should be people responsible for the secure design of their internal development infrastructure. And so that would be one important, if not the most important, target audience of this document.
Security architecture example?
Yeah, I would say security architecture of the built environment. So the company that I've been working for before, SAP, they had there it was a highly specialized organization, right? You had a central security team, and then you had teams operating security tools, and then of course you had security architects within the application development teams. And so from my perspective, it should be the people, the security architects of that build and development infrastructure. They are the primary target audience. But there are also other stakeholders, let's say, such as the developers when it comes to securing their workstation, where there is a lot of malicious stuff also consumed or can be consumed, potentially consumed. And I think also individual development teams. I think some depends a little bit. I think it will depend on the safeguards from OpenSSF that we will use to mitigate the different threats identified. And some of those safeguards will be developers and others for the architects of such infrastructures, and some others for the development teams. But of course, even though maybe the users of those safeguards are those individuals I just said, there's probably some guidance also required in order to top down make the people aware of it and tell them how to do it in a specific organization.
Yeah. Thank you.
So and that again depends on the specific organization, whether there is a central security team taking care of producing such guidance and such requirements, or whether this is all distributed. It's difficult to make some assumptions on how software development organizations look like. They seem to be all different in a good way, let's say.
Yeah. Okay. Yeah, I will take a look at this document more deeply.
Hey, good morning, Henrik. Victor.
Hi.
Sorry, I'm late. So actually, last week you didn't had a conversation with Crow. So I basically the actual attack vectors that you have considered in this diagram. I wasn't familiar with. That's why Crow pointed to your taxonomy white paper. Great white paper, by the way, very useful. One thing I think be useful for this discussion, because that white paper have a lot of information, but is there like a spreadsheet that's include all the attack vectors and that you can share in the channel, or?
Yeah, well, we do not really have an Excel sheet. What we thought, when producing this taxonomy of attack vectors, we understood that it is difficult to consume in a PDF on archive, and so we created this online tool. So I can, and in this online tool, you can basically explore the attack tree, and on each attack vector in the tree, you will get a description and references to either academic works. I can just browse you through the thing.
So it's not even, it's even better than spreadsheet in that case. So you actually have a trick.
Look, it's not so difficult to be better than Excel spreadsheets.
Okay.
Even though I acknowledge their kind of universal use, and also now they're also very useful, of course, very often. And let me just open it, and then I can walk you through it.
Yeah, that would be awesome, because while we're going through this, I'm interested in it, but my biggest problem is I don't know the possible attack vectors. I know your research basically gone through a lot of literature, gather almost very comprehensive list of attack vector, right? So if you have that, and it's possible, sometimes there are like new vectors that's not in there that if I find one, I can share that. Yeah.
No, I can walk you quickly through it. Would be a pleasure.
Okay.
So this is basically an interactive online tool. This one here is hosted at Endor Labs. It is basically the same as the one that was originally developed by Cybersecurity Research. They also maintain and run this in parallel, kind of. And here we basically see this attack tree, right? And so the root node of the attack tree is the high level goal of conducting an open source supply chain attack, meaning to inject and spread malicious code to downstream open source consumers. And then if you drill down for each of those attack vectors and nodes, you will basically see all those nodes represent alternative ways to accomplish the respective super goal, right? So here you have all those name confusion attacks like typo squatting and so forth. And then here it's getting bigger and bigger. You could inject malicious code into the sources of a legitimate package during the build, or by tampering with the distribution mechanism. And for each node, you have here a description, references, and you see that references are typically here either peer-reviewed academic papers or attacks, and then we sometimes also have frameworks or so. And on the right-hand side, we have safeguards that to some extent
Okay.
mitigate the respective attack, right?
Yeah, I think you actually shared this. At that time, I just didn't pay attention, I guess. So my question is, this is very nice for drill down, but if I want to see a whole list, especially which part of the CI/CD pipeline this particular attack vector is related to, is there such a list?
We have here, now we have here kind of a table as well, but this is, yeah, this is a table. But maybe I'm not sure whether it's so useful for exploring them and grouping
so let's
them,
say
right? So
if I'm interested in like like you discussed with Probe the other day, anything related to laptop, right? For developers' laptop, which attack vector is related to that? How do I find out?
No, we don't have a view like this. This is the well. Let me. This is not so easy. Let me see if it is possible. No, this is another dimension, kind of, to look at all those vectors, and it's not a dimension that we support in terms of visualization of filtering or so. Because
yeah, so this is more...
if you think of it, here let's take this one, all the name confusion attacks, typo squatting, brand checking, and so forth, right? This is something that is relevant for the developer workstation. They would typically install something locally, maybe to just play around and create a proof of concept. So all this matters. But then also here, when it comes to injecting into sources, also here the developer laptop matters, because if you, for example, install a malicious plugin that could change the source code of the project you're working in and make you commit something malicious into the source code repository again. Or maybe you have a weak configuration of your workstation that would allow some attacks. So this is yeah, it's not so easy to filter this.
Yeah. So let's say because SOSA 1 just released, so I say, okay, SOSA 1 is interesting. I like to understand SOSA more. In the meantime, I'll use this tool, this taxonomy tool, as well as the diagram you're developing. So from here, how do I find this? Which one is related to the build phase? In other words, related to SOSA, related to the attack vectors.
This one is here, right? So here the attackers have the possibility to inject malicious code during the build of the legitimate package, and that can be done according to the taxonomy in those ways, and this again can be refined and so forth.
Okay, so what else? What other? How do I find all the attack vectors that's related to build phase?
No, I think all that is related to the build phase should be here below. Inject during the build of legitimate package. That at least would be my hope.
So this is the top level of the tree.
I mean, no. Or let me phrase it a little bit different. And I think this is an important distinction. I mean, this is these are the attack vectors targeting the environment of the open source project. So if I speak here of inject during the build of the legitimate package, so this would be the build of the open source project. It is not the build of an application developer depending on that package, right? So this is also, I think this is important to understand. And basically we need to, and so the effort, and that is part of the whole exercise, is to use this taxonomy and derive some threads for the end user, the application developer, basically. And it could very well be that, let's say, some of the controls to be implemented by application developers are the same ones, independent of how the malicious code ended up in the open source package in the first place. But this, again, this is an exercise that I would like to run through basically attack vector per attack vector, or maybe by groups of attack vectors, and discuss this then vector by vector.
So what's on screen right now is the top level of the tree, right?
Yeah, here on the left-hand side, you have the top level. Yeah.
Okay, got it. Okay, I got it. So from here I can drill down, which is sort of give me an idea of what the text vector list in each category. Yeah, okay, I got it. I think it's useful. Yeah, I'll review this. Very useful. Can you share that?
Yeah.
Is that shared in the channel?
I can share. So there are two versions of the whole thing. I share you both. So
yeah, I think that's the problem. Without any background knowledge, you're just learning bit by bit every time you talk. So it'd be great to have this to prepare a little bit beforehand.
Right, and you see this is the tool as it is still run and maintained by SAP, and it's basically the same thing here. Yeah, I would be happy to receive. I mean, when we built this, like what do we have? It's 1 year ago, a little bit more than that, maybe. We paid attention to have proper descriptions and really do our best to have all definitions well aligned. So, but I would be happy to receive your feedback. In particular, we ran a user survey, both with experts in supply chain security as well as with developers, in order to get their, input on whether this is an appropriate taxonomy, about the names we gave and the descriptions and so forth, in order to make sure that this is as accurate as possible.
This is great, thank you. So the Andor Lab one is more recent, right? More up to date.
No, they're both the same. We really we really collaborate with SAP here to have this up to date, and there's no difference whatsoever.
So it's exactly the same?
It's really exactly the same. It's just two ways of consuming the same thing.
Okay.
Right, and I think, please.
Yeah, so on what data you base this tool on? Like, what's the core database comes from?
The core database is basically around 300 something papers and from scientific and gray literature, as well as a text. I think overall the statistics are, I don't know where, but I think we have more than 100 attacks, real world attacks that we relate to the different vectors, and then another 200 something papers, blog posts and stuff. And there's and for that matter, we have here basically you find all that in the references. But I don't have, okay, it's a little bit more in the meantime.
Nice. Yeah, it's really good job. This is the first time I see the real database that has an interactive aspect that I can play with. This is highly valuable.
Yeah, what we basically, we started working on this because we thought that there are many individual blog posts and the terminology was not properly defined, and so we thought it maybe makes sense to have a proper taxonomy.
Yeah, and this is focused mainly on software supply chain, right?
It's focused on, in particular, open source supply chain attacks. So we do not, I mean, there is a good overlap, I think, but some of the particularities relate to open source components in particular. But I think we also included SolarWinds and a couple of other attacks on commercial software providers. But the initial goal was really mainly on open source projects and how they are attacked.
Yeah, because I saw some aspects that comes from the CI/CD security, the security of the pipeline, right? Which is basically not open source, right? It is process, the CI/CD process.
I mean, yeah. Well, yeah, it's true, but I mean, every open source package that is packaged and made available on PyPI and so forth, they need to go through a build process somehow, somewhere, either on the developer computer or on a Jenkins system or God knows where. And so this is why it also matters for open source packages.
Right.
And this is why, which is why many of the threads apply both to commercial software development organizations in the same way as they apply to open source projects.
Right. Thank you.
Yeah. And I mean, one hope that we always kind of had when developing this thing is that you could basically select safeguards and then prune the tree. So if I have implemented this tree, maybe let's say I do build this is a good example. So say I build my dependencies from the source. I do not rely on prepackaged components on PyPI. Then I basically can prune the tree and get rid of a couple of leaves, because it doesn't matter whether an attacker is attacking the open source project's build system or whether they attack PyPI, because I'm consuming my stuff from GitHub. And so I think this whole visualization can also be used not only to understand the subject matter, but also to basically understand where do I have open issues, open problems, how well am I covered in terms of mitigations and so forth. And the other thing we also thought is that this can be used actually to scope penetration tests. You basically go to a penetration tester and say, and this and this and this and this, here you can play, and here the other things don't, please, this is out of scope of the pen test.
Yeah, yeah.
But right, and this whole, and maybe then to close the loop to the threat modeling workshop, John Meadows, he was doing a threat model himself for his company, basically for their own internal infrastructure, and he was using this taxonomy already in order to basically locate threats in their internal infrastructure. And we wanted to redo this in a broader, in the broader community with more inputs. Yeah. The other example, I have so many ideas for this thing, I just no time to do it. I always also thought that we have already examples. So all the real world attacks, it would be nice if somebody could just enter the name of a malicious package or so, and then we can basically locate the vector that was used in order to conduct that specific attack, or to spread this specific malicious package. But yeah, well, ideas. Good.
Can you refer to some similar or other tools that out there that serve the same purpose approximately, if there are? The one that you know of.
No, I'm not aware of any other tool. I think what is different here is we really wanted to take the attacker perspective. The other works, such as Salsa or software component verification standard, they more take the defender perspective. And yeah, so no, I don't know of any other tool.
Yeah, yeah.
Good. All right. So I would love to. Do you think I'm not sure whether it makes sense to start going through these data flows? Yeah. What do you think?
Yeah, at least from my side, I will have to review this page at least once before I have something to say about that.
Yeah, no, fair enough.
Maybe it'd be helpful, I said, especially for me, I'm new to security overall. That the tool is very useful. I don't know if you have time, maybe the future might be use that tool to drill down to each attack vector category and see where they fit on this diagram.
That is exactly the exercise that we are going to do, I hope, as soon as possible. It turns out it kind of takes some time to run through this diagram and fill those tables or so, and until we get to the actual threat modeling where we will go through those attack vectors. Yeah, I don't know. It's just that I think this is, but I think it's important to kind of do this together. I do not want to sit down and then just propose something and then maybe some people just tick it off without really properly reading or God knows. And so that's why I want to primarily progress during those meetings. But then again, there are, some people are not there and summits take place and God knows what, life happens.
Yeah, I know if they're experts like Crow probably can give input. So for me, maybe it can be reversed. Instead of waiting at the end to try to match the threat vector into the diagram, at least for me, it'd be helpful to kind of even not formally just go through it. So this is the attack vector for build phase, and so let's drill down, and this fit into this box, the other fit into the other box, and why it is. And this way, you can even post in the channel. I don't know whichever channel you. Okay, yeah, in the the OpenSSF for that channel. If you can post like beforehand, this is a topic for today. We're going to drill down into build. So review everything under that build threat model, and get familiar with what attack vector that's in there, and add anything that's you're aware that's not even included in that model in the graph. And this way we can come and discuss and just go through this. So is anything even missing from that diagram, that graph database? And yeah, I think that'd be helpful for me at least.
Yeah, no, that's a good idea. Maybe I just come up with a topic that we are going to discuss a little bit before the actual meeting and say, okay, now we are talking about, I don't know, the build process or the internal binary registries and so forth.
Yeah, this way, if you refer to one of the subcategory of that attack vector graph diagram, I can drill down beforehand and read everything. I know not in detail, at least know which one which. This way, when I come back and take a look at this, I know which. I know what you're talking about.
Okay, so basically, it will be basically pointing to maybe an element of a couple of data flows in the diagram, as well as some nodes in the detect tree, and in order to better define the scope and the content of a particular meeting, right?
Yeah.
That's a good. That's
for me. It's easier to follow the attack tree graph database because it's more in one category, right? Because here, if I say build, that build might include multiple entries from that tree, the attack vector database. But if I go to the attack vector database, I can just drill down everything in that one branch, and I can tell whether it's part of a build, Git, the production, whichever it is. It's easier that way, I think.
Yeah, no, makes a lot of sense. I will take this to do with me and be a little bit more, or propose something for the next meeting. All right. Good. Good. Unless, I don't know, Itai, do you have any other question or comment?
No, actually not. I have enough materials to overview. So, yeah.
Yeah, and I hope my introduction and overview was somehow helpful.
Yeah, it was very good. Thank you.
All right. Then I think we can, if you don't mind, call it a day, or maybe not yet a day, but call it a meeting. And I hope to see you next week with more people coming from Vancouver, back from Vancouver again. All right.
Thank you.
Thank you both, and I wish you a lovely afternoon.
Thank you, Henrik. You
You
too.
too. Bye.
Bye-bye.
Bye.